Hello students, in this video I will show you how to answer the question from homework number 13. This is question number 3. The question says, you wish to test the following claim, the alternative hypothesis HA, at a significance level of alpha that is equal to 0.005. So we have our null hypothesis and alternative hypothesis. As you notice here, it's a right tail test, and we have P, which is equal to 0.5. You obtain a sample of size n is equal to 524, in which there are 284 successful observations. For this test, you should not use the continuity, and you should use the normal distribution as an approximation for the binomial distribution. What is the critical value for this test? And we want to find the test statistic. We would like to see if the test statistic is inside the critical region or outside the critical region, and we will make a decision based on that. So let's start by finding the critical value. So from the question we have x is equal to 284. We have n equals to 524. And we have P naught, which is 0.5. We have alpha, 0.005. We can compute P hat. P hat is equal to x divided by n. And then we are aiming for the z critical, or the critical value. To find the critical value, we know that the test is a right tail test. So I'm going to demonstrate. So here I'm going to try to draw the region. Here's my distribution. We're using the normal distribution in this case, and it's a right tail test. So this region is given, which is alpha, that is equal to 0.005. And I want to find the z critical. To find the z critical, I'm going to use norm dot s dot inverse, and then I will use the area to the left. So the area to the left of z critical is basically 1 minus 0.005, which will give me 0.995. So I will go ahead and plug that in here, 0.995. So I will compute that in this cell. Norm dot s dot inverse of 0.995. So the critical value is this number. I'm going to copy it and paste it right here. Next, I will try to find the test statistic. The test statistic has a formula, and the formula says that z naught, or the test statistic, is equal to p hat minus p naught divided by the square root of p naught times 1 minus p naught divided by n. P naught here is the proportion of the null hypothesis, which is given in the question. So I will go ahead and use that formula to compute the test statistic, or z naught. That is equal to, I'm going to put parentheses, and p hat is equal to that value, minus p naught, which is this value, divided by the square root of p naught times, open parentheses, 1 minus p naught divided by the sample size, which is 524, and then close parentheses, and that is the z naught, or the test statistic. So I will go ahead and I'm going to put that in here, submit my answer. Next, we will determine whether the test statistic is in the critical region or not. So let's go back to Excel and I will explain. Here's my critical region right here, because this is the critical value, and anything above that, if the test statistic happens to be in this region, then it will be too far away from the population proportion, and we will reject the null hypothesis. So let's put the numbers and see if it's inside or outside. So I have the Z critical, or the critical value, to be 2.58, and then the test statistic is 1.92. So 1.92 is obviously before that number, so it is approximately right here. That is 1.92. So basically, Z naught is outside of the critical region. It is not inside of the critical region. So I will select that it is not in the critical region. And then I will proceed with the rest of the question. So based on this test statistic, do we reject the null hypothesis, or accept the null hypothesis, or fail to reject the null hypothesis? We never accept the null hypothesis, so that is eliminated from the beginning. And looking at here, the test statistic is outside of the critical region, or I call it the rejection region. And since it's outside of that, I'm not going to reject the null hypothesis. So the right decision is to fail to reject the null hypothesis. And I will proceed with the rest of the question. So based on what we did here, what is the final decision? There is sufficient evidence to warrant rejection of the claim that the population proportion is greater than 50%. That is not the case. There is not sufficient evidence to warrant rejection of the claim that the population proportion is greater than 50%. Let's read the rest. The sample data supports the claim that the population proportion is greater than 50%. That is not true. There is not sufficient evidence to support the claim that the population proportion is greater than 50%. So which one is correct? There is not sufficient evidence to warrant rejection, or there is not sufficient evidence to support the claim. So I'm going to say there is not sufficient evidence to support the claim that the population is greater than 50%. And that is the right answer. So I hope this video helped you, and I will see you in a different one.